Greetings. The Mathematics Foundation, the South African Mathematics Foundation, has been administering competitions, mathematics competitions, throughout South Africa for many years. And amongst the competitions that it administers are the South African Mathematics Olympiad, as well as the South African team competitions. The Olympiad competitions go over 3 rounds for juniors as well as seniors. And so every year there are 6 papers which I set. This series plans to unpack the problems that were set in 2023, 2024, and 2025, which means that there are 18 such sessions. In addition to that, the series also aims to unpack the problems that were set in this team competitions. And the team competitions consist of 2 rounds. One is an individual and the other is the team. And several teams of 10 participate right throughout the country. And again, you have 2 divisions, the junior and the senior. And once more, for those same years, 2023, 2024, 2025, we will try to unpack those problems. So that makes 4 each year, so that'll be 12 such sessions. And this is one of them. Today we are going to do the 2024 team paper as opposed to the individual. And this is a paper which was asked of the teams of 10. They all get together and they try to solve these 10 problems. It's not individual, it's a team effort. So with those few words, let me go. Okay, so as you can see, we are speaking about the South African team competition 2024. And the very first question is the following. Let A and B be non-zero real numbers. We know that out of the 4 real numbers, A plus B, A minus B, that's the sum and the difference of those 2 numbers. And AB and A over B, which is the product and the quotient, 2 are positive and 2 are negative. The question is, what is the sign of the number B? In other words, is it positive or is it negative? All right, one of the things we have to notice is that AB is either, if AB is positive, it means that either A and B are both positive or A and B are both negative. Right? And also that AB and A over B have the same sign. In other words, if AB is negative, so is A over B. And likewise, if AB is positive, so is A over B. A little bit of thought will be able to understand those last statements. Okay, what is the sign of the number B? I'm going to prove, let's take the cases. Let's take A over B. Now, suppose B is positive. If B is positive, let me just try to improve the writing here. Now, if B is positive, then let's see, there are two cases. AB is negative. Oh, it does improve it. Right. If AB is negative, B is positive, then A is negative, product of. And now you got A is negative and B is positive, and so is A over B, because A is negative and B is positive. Now this is not possible because you can't have three negatives. It is given that only two of them are positive. Okay, the same thing happens if AB is positive, then we are given that B is positive, therefore A is positive, and therefore A over B, both of them positive. Once again, you got three positives. So neither is true because only two positives. It's given that two of them are positive and two of them are negative. So the conclusion is that therefore this assumption is false, therefore B is negative. That's the answer to the question. All right, let's get on to the next one. It's customary to give all the solutions to all the problems beforehand. So, and I use that as a checking device. So let's go to my solution and see. I expose this. I'm not sure whether I did it in exactly the same way, but you can go through it in case you have any doubts as to how to solve this problem. Okay, let's get on to question 2. Question 2 says A and B are real numbers and star is an operation. Okay, so that means that those two numbers, you can create a third number out of them by a rule. So that's what you mean by operation. Like plus is an operation because you can create from two numbers A and B a rule which says A plus B. Like that, you can create A minus B or AB or A over B. There's some rule which connects A and B. But in this particular case, the rule that is given is A squared minus 2B. Right, so let's just write this down. This A star B is equal to A squared minus 2B. So to give an example here, like for instance, 5 star 3 is the first one squared minus twice the second one. So it's 5 squared, which is 25, minus twice the 3, which is 6. So you get 25 minus 6, and this is 19. All right. Now, you're given two equations. Find all possible values of y if x star x is equal to 8. So x star x equals 8. The first is squared, right? Minus twice the second. The second is also x, and that is equal to 8. So this tells you you've got a single equation involving x and 8, and that's a quadratic equation. And it factorizes. The values of x are 4 or negative 2. And they say A and B are real numbers, so both of them are fine. Both are acceptable. Okay, now you got another equation which says 3x star x star y is equal to 30. Now, according to the rule, the first is squared, and you subtract. So this is 9x squared, first is squared, minus 2y, minus twice the second, is equal to 30. All right, now we need to calculate y. So I'm going to make 2y the subject. So bring 2y on the right-hand side. I got 9x squared minus 30. And we saw that there were two values for x, right? So it's 9 times 4 squared minus 30, which is equal to 1644, 114, or 9 times negative 2 squared. With the other value for negative 2, x was negative 2. So this is 9x squared, 9 times negative squared minus 30. And that is 9 times plus 4, which is 36 minus 30, which is 6. So the question is find all the possible values for y. So the answer is 114 and 6. These are the, oh, wait a minute. This is 2y. So if 2y is that, then just have to be careful here. Then y, the question is what are the values for y? Then y is 57 or 3. Okay, so you have, the question was to find the values for y. Okay, let's just check my solution to see whether my prepared solution is the same thing. Okay, you got y equals 57 or 3. You see, this is not answering the question. So this is wrong. Always try to answer the question. Question is find the values for y, not the solutions. So the two solutions, we should say 57 and 3. Okay, those are the solutions because the question asked for y. All right, let's go on. We go on to the next question, which is question 3. Question 3 says the following: candles X and Y are lit together. Candle Y lasts for 7 hours, and I'm sorry, candle X lasts for 11 hours, and Y lasts for 7 hours. Okay, they burn off. These candles, they've got limited lifespans after they are burnt. Now, after 3 hours, both candles have equal lengths. Find the ratio of the original length of the candle, X, to the original length of candle Y. All right, let's candle X and candle Y. We don't know what the original lengths are, so we can call them. Well, let's call them X. This is candle X, so we'll call the little x and the little y. So we are letting X and Y be the original lengths. So we need to find X and Y. Now, candle X lasts 11 hours. So after 11 hours, this thing comes down to 0. And I presume it's burning evenly. So we can say what happens. Usually in problems like this, you bring it down to a unit. You need to know what happens after 1 hour. Okay, let's do that. After 1 hour, okay, it lasts for 11 hours. So in 1 hour, 11 over x I'm sorry, x over 11 of the candle is burnt off. So in 11 hours, entire x is burnt off, right? So in 1 hour, this is burnt off. So let's see what remains. X minus x over L is the length. And we can do the same thing for candle Y and say after 1 hour, it started off with Y and it lasts for 7 hours. So Y over 7 burns off in 1 hour, because in 7 hours, you got the entire thing is burnt off. It lasts for that period of time, so it burns off completely. And therefore, after 1 hour, Y minus Y over 7 is the length of the candle. Right. Now it says here that after 3 hours, both candles have equal lengths. So it means that after 3 hours, its length will be that. So let's just say 3 into x minus x over 11. This is its length after 3 hours. Each hour no, wait a minute. I think I'd better be just a little bit careful. What we should say is, I don't want to know what the length is. I want to say x over 11 is or disappears or burnt off. I don't like the language, but anyway, burnt off. And the same thing with. Right, so after 3 hours, how much is burnt? I'm going to be just careful here. I think after 3 hours, you will have 3x over 11 is burnt off. So the length of the candle will be the original length minus what is burnt off. And the same thing with the y. After 3 hours, 3y disappears, and the length that remains is that. And they say that after 3 hours, both candles have equal lengths. All right, so this is what you've got here. Now find the ratio of the original length of candle X. In other words, this is the original length to the length Y. So our ratio will be that. So that's the question that we're looking for. We have an equation. That's the answer that we're looking for. We have an equation. Let's try to see what we can do with this equation. You have to multiply on both sides by 77. That's a large number. Oh, wait a minute. This gives you 8x over 11. That's easy. This is 11x over 11 minus. And here you've got 7y over 7 minus this is 4y over 11. That's 7y minus 3y. It's 4y. So we are looking for x over y. Okay, let's cross multiply. 8 times 11. 8x times 11 is 88x equals cross multiply is 44 over 7. This is over 7. Right? 44. Sorry. Let's do this again. So 8x over 11 is equal to 4y over 7. 4y over 7. If you cross multiply, you get 56x equals 44y. That's 4y. And x over y. But be careful here. Sometimes people say x over y is 56 or 44. That's not true. Looks like x, y, the x over y is 56 over 44. That's not true. Because you're cross multiplying, you see. This, yeah, you'll have to have 56 at the bottom here to get 56x, and you have to get 44 at the top to get 44y. You see? So it's not 56 over 44, but it's 44 over 56. Well, you can simplify this. 4's cancel, and you get 11 over 14. So this is the ratio, 11 over 14. Many of these problems, you bring it down to the units. In other words, bring it down to 1 hour. And then you can use that as your launch pad to work out for any number of hours. Once you bring it to 1 hour, then the problem becomes very much easier to solve. All right, let me see what solution I had to this problem. And I might have done it in some other way. Oh, very quickly I've got the answer. So, oh, it's exactly the same thing. Well, I also used x and y in my solution. So, question 4. Find the smallest integer n that cannot be written in the form like this, where a, b, and c are positive integers. So all these are positive integers. So none of them is equal to 1, right? Because they're all positive. If any one of them was 0, then you have 2 to 0 is 1. The a, b, and c, a, b, c, d are all exponents. So they're all greater than 0. So none of these are 1. So you want to write a random integer like this, and you want to know what is the smallest integer that cannot be written like that. Okay, so let's try to solve this. So we start with all the integers starting from 1 until we cannot do it anymore. And then we will say that that will be the smallest integer. Okay, so let's start with 1. So 1 is equal to, well, obviously you can't put 2 minus 2. Oh, you can make it, denominator is the same. Right. So that numerator and denominator is the same. So 1 can be done. It's not the smallest. Let's try 2. Now, the one useful thing I found when I did this was that 1 is equal to 2 minus 1, which is quite obvious. But you can divide by 1, you see. Any number is equal to itself divided by 1. So you can make the denominator 2 minus 1. But you don't want a 1 here. So at the bottom. So you have to multiply the numerator and denominator by 2 or something, and then the 1 disappears. But you can multiply both. You'll see how it works now. 2, for instance, is equal to 3 minus 1. No, you don't want 3 minus 1. You want 4 minus 2. 4 minus 2 is 2. Now, how do you get to this? Watch. 4 minus 2 over 2 minus 1. That's 1 at the bottom. And then I multiply. 4 is 2 squared. I wrote this as 4 minus 2 because this is 2 squared minus 2. So this is, let me write that 4 as 2 squared. Now you multiply numerator and denominator by 2. I don't want a 1, you see. So it becomes 2 cubed minus 2 squared over 2 squared minus 2. Multiply both numerator and denominator by 2, and that gives you 2. So you can watch this. You got 8 minus 4, which is 4, over 4 minus 2, which is 2. So 4 over 2 is 2. Okay, so it's their starting point is you have to subtract 2 powers of 2 to get to where you are. Like if you take 3 now, this is 4 minus 1. And this is they're powers of 2. 2 squared minus 2 to the power of 0. And as we said now, this is 2 squared minus 2 to the 0 over 2 minus 1. Right? You don't want, and this is also 2 to the 0. So you multiply right throughout by 2, and you'll get 2 cubed minus 2 over 2 squared minus 2. Right? And check it out, you get 8 minus 2 is 6, and 4 minus 2 is 2. 6 divided by 2 is 3. So 3 works. Now, you can try all these. Yeah, you can start with 8 minus 4 and do the same thing, and you will see that it works. If you try 5, now this, you'll find that you can't write this thing very quickly as something. But yeah, what you have to do is you say that this is 5 over 1. And you see how far it is to the next power of 2. Uh, 5, you can get 15 over 3. Now, why do we do that? Because this is 16 minus 1 over 4 minus 1. You see, there are different ways of writing 5, but I've written it in such a way that both of them are at the same distance from a power of 2. This is 1 unit from 16, this is 1 unit from that. And once you do that, then the rest follows, because this is 2 to the power of 4. I don't want a 2, I don't want a 1, so I can multiply this by both multiply both numerator and denominator by 2, and there you are. So 5 can be done. Now 6 is equal to 2 times 3, and we already had 3. 3 is that one. So you simply multiply this by 2. So if you multiply the top by 2, you have 2 to the 4th minus 2 squared over 2 squared minus 2. So 6 works. Now 7 is 8 minus 1. And that's the power of 2 minus the power of 2, and you just proceed as usual. And 8, well, 8 is, it's a power of 2. It's actually 16 minus 8, right? And again, you got a power of 2 minus a power of 2. So you just proceed as before, and you'll get to this form. Doesn't seem to be ending here. The 9, it takes a long time. It took me a long time to get to this, but it's the same trick that we used in the 5. And we'll see, you write this thing as a fraction, and you see that's actually 63 over 7. This is 1 unit away from 64, and this is 1 unit away from 8. So if you take 9, 9 is 64 minus 1. That's 2 to the 6 minus 2 to the 0. And this is 8 minus 1, 2 cubed minus 2 to the 0. And as usual, you just multiply numerator and denominator. 9 is taken care of. And 10 is also can be done like this. But you see that this time it becomes like 30 over 3. And this is See, and this is 2 units away from a power of 2. So it's 2 to the 5 minus 2, 32. And this is 2 squared minus 1, right? So you write it as in such a way that its distance from power of 2 is again a power of 2. And then now you have to just multiply the numerator and denominator by 2, and you will get 10 as well. Now, this is a very tedious. I don't think this is a fair question, because it turns out that 11 cannot be done. So all the numbers from 1 to 10 are okay. They all can be written in that form, but 11 cannot be. Now, it's not easy to show that some number cannot be. You have to write it as fractions, as, I mean, kingdom come until you see, to see whether some power of 2 must be added to the numerator to get another power of 2, and likewise the denominator. And you see, you try, it doesn't work, but it's actually impossible to do it. So let's try to prove that 11 cannot be written in that form. 11 cannot be written in this form. All right. Now, to do this, you prove by contradiction. Right? By now, you should be able to be aware of proof by contradiction. And that is where you assume the opposite. Suppose it can be written. Then you eventually come to something that is impossible. So you suppose that 11 is 2 to the A minus 2 to the B, or 2 to the C minus 2 to the D. Now, you can assume that both the numerator and the denominator are positive, in which case you've got the 2 to the A is greater than 2 to the power of B. You can take out 2 to the power of B as a common factor. And when you take it out, I'll repeat that. You can assume that both numerator and denominator are positive, which means that this 2 to the power of A is greater than 2 to the power of B. So we'll take out the smaller power. So this is equal to, we can factor it out, in other words. We'll take the 2 to the power of B into 2 to the power of A minus B minus 1. And the same thing with this. This will be greater than that. 2 to the power of C is greater than 2 to the power of D. You can take out the smaller power. Right? And then you have 2 to the power of B minus D, because you got same base. You can subtract the indices. And here you have, let's call this A minus B, we'll call it M. C minus D, we'll call it N. Now, remember, on the left-hand side, you got 11. And this is an integer here. Right? So it means that 2 is not a factor of 11. When you factorize 11, you're not going to get any power of 2. So it means that B and D are the same. This part here is 1. Right? It has to be 1. In other words, b is equal to d, 2 to the 0. Right? So now you got 11 is equal to 2 to the power of m. Let me write this m clearly. Often when I use m and n, maybe that is why I should use something else. The m and the n look identical. 2 to the m minus 1 over 2 to the n minus 1. All right, now I'm going to claim that this is impossible. You can't get this fraction equal to 11. So let's cross multiply. And you will see, if I make 11 times 2 to the power of n, your subject, I'm going to take 2 to the m minus 1. There's a minus 11 here. I'm going to take the minus 7 and put it this side. It becomes plus 11. And here you have 2 to the power of m plus 10, which means I can take the 2 out. 2 is a common factor. Okay, so suppose m is greater than 1 or greater or equal to 1. Now, I want it to be greater than 1. Suppose m is greater than 1. Then I can take the 2 out from this. You get 2 to the power of m minus 1 plus 5. Right? Now, if m is greater than 1, this is even. And this is odd. So you got an even plus an odd here. This is odd. So you got 2 times 11, 2 times an odd number. So this becomes even. Oh, let's put it this way. So you have, I'll take off the 2, I'll make this 2 to the 11 times 2 to the n minus 1. Bring the 2 to that side. And here I have an odd number. When I take the 2 to the other side, because I'm assuming that m is even. I mean, m is greater than 1. So this is even. If m equals 1, then this is equal to 1. You see, that becomes odd. That's the only time this is an odd number, when m is equal to 1. The rest of the time, it's an even number. I'm assuming that. Then I get that this is odd, which means that 11 times a power of 2 is odd. So that means that n is equal to 1. So if m is greater than 1, then n equals 1. All right? So let's go back to this equation here. Just going to create some space here. There's an important equation that we are working from. Let's just keep that in mind. It's 11 times 2 to the n equals 2 to the m plus 10. Right? That's the equation that links m and n. So n is equal to 1. If n equals 1, then this part is 2, and you get 11 times 2 is 22. And then you have that 2 to the m is equal to 22 minus 10, and that's 12. Now, no power of 2 can be equal to 12. So this is impossible. So m is not greater than 1. Right? Because if m is greater than 1, then that implies that n is equal to 1, and you come to an impossibility. So this assumption is false. M can't be greater than 1, which means that m is equal to 1. But now you take the same equation if m equals 1, if m equals 1, then you got 11 times 2 to the n. Now m is equal to 1. So 2 plus, again, you got 12. So no multiple of 11 is equal to 12. So this is also impossible. Right. So in other words, it's impossible. No matter which way you turn, you'll get to an impossible situation. Right. And therefore, 11 cannot be written. That was the assumption that we made. It cannot be written. We said it can be written. And we came to a situation where we meet a dead end no matter which way we look. All right. So what does this mean? It means that 11 is the smallest integer that cannot be written. All the other ones we showed can be written. The answer is 11. It's not a nice question. I think it's a very unfair question. But when you come to 11, you don't really know that it's impossible. It takes a long time to prove that 11 cannot be done. Yet in all the other cases before that, we found ways. All right, so let's now check to see what the answer was. Oh, I got your answer is 11 here. But again, I wrote down all these, almost like guesswork. But my solution is very much better because I systematically try to write these numbers in that form, not just by guessing like the way I did here. All right, let's get to the next question, which is question 5, I think. A geometry problem. There should always be a geometry problem. Okay, so what do we have here? For the isosceles triangle ABC, ABC, so this is isosceles, AB equals AC. All right. And you got the third angle is 110, which means we can calculate angle B and angle C. All right, we'll just leave that for the moment. And angle CAB is 110 degrees. Two equilateral triangles. So APC, this dark one, is equilateral, and this is also equilateral. So all the angles there are 60 degrees. Right? They are drawn on the sides AC and BC. Right? Now they say extensions of BA per, so this BAQ is a straight line. It meets this thing. If this is extended, it meets it at some point. And then at that place, you can see that angle there is bisected, and it meets the bisector of this angle at S, because you can see these angles are the same here. Right? They mark them to be the same. So they meet at this point S. Find QSR. QSR. So this is the angle that we are looking for. So just bear in mind, you've got equilateral triangles, and these angles bisected. So all these angles are all, no, that is not 30 degrees. You have to be careful. This is 30 degrees because this is an angle of, well, the whole thing is 60, so half of that would be 30. But here some extension is going on. Okay, let's try to calculate this angle QSR. I've redrawn this here so we can do what we call angle chasing. All right, remember we said AB is equal to AC. Now we need to get QSR. That's your X. Now, if this is 110, these two add up to 70. So each of these is 35. Okay, what else do we know? We know that these angles are 60 degrees. Now, look, first let's just look at QSR. What do we know about QSR? It is one of the angles of a quadrilateral in this picture here. SQCR. So we'll try to examine the angles, find all angles of the quadrilateral SQCR. Then if I can find the other three angles, you see that I'm encouraged by the fact that this is 30. I already know one of the angles of that quadrilateral. So we're looking at the quadrilateral whose vertices are these. Now we don't know these two angles here, but we do know that this angle is bisected. Okay. So do we know this one? Well, this has been extended to get to that. So this angle here, okay. Okay, let's have a look at this one here. This is easy. This is 60, this is 60. Right, so we've got two angles of that quadrilateral. If you can get this one, then we can calculate that one. Now, these two angles are the same. Okay, now this angle Q, this entire angle Q, is an angle of QBC, you see. And we know that is 35. We know this is 95. So angle Q plus 35 plus 60 plus 35 is 95, is 180 degrees. And this is the angle that we're talking about here, angle Q. Not P now. At angle P is 60 degrees, right? But that angle. So these two add up to 130, so Q is 50 degrees. And that's nice because now it means that these two angles, the entire angle is 50. So this angle here is 25 because this angle is bisected. Oh, but now you can work out X. It's not such a difficult problem because you got the remaining three angles. So you got X plus 25. This whole angle here is 60 plus 60, 120, plus 35 is 155, plus 30 is 30, and plus X. Oh, okay, I already got that. Now these are the four angles of this quadrilateral, and they will add up to 360. The sum of the angles of any quadrilateral is 360 degrees, and this gives you X is equal to 150 degrees. These two add up to 180. So 30 plus 150 is 180. There are two 180s here. So X is 150 degrees. So actually it means that these two lines are parallel because this is 30 and this is 150. So it turns out that this line here is parallel to this line. Anyway, let's just see if X equals 150 is correct. Oh, I wiped out my solution. All right. Oh, that's the solution. There it is. There it is. QSR is 150 degrees. As you can see, it's some small writing there. All right, so that's question 5, I think, and we can go on to question 6, which is, oh, this is a long essay here. All right, so let's read this question. I'm not going to read the whole thing one time because you'll lose everything. I'll forget everything by the time I get to the end. So let's just build this thing up. Right, there are 3 towns, A, B, and C. So let's draw the towns. I'm going to put it down in the corner here. Let's just put that in the form of a triangle. 3, A, B, C. All right. Okay, a person walking from A to B, driving a car from B to C, and riding a horse from C to A completes the journey in 55 hours. All right, so it gives you the total time that it takes to complete the journey from A to B, from B to C, and C to A. But now we don't know what the speeds are. We have to give names to the speeds. The walking speed, let's give a name. Let walking speed, driving, and riding. We'll give a name to these speeds. Just to keep track, I'll call it W, D, and R. There's W, D, and R. These are the speeds for walking, driving, and riding, which means that we say that this thing takes 15 hours. So when you are, let's do this, walking from A to B, let's put a W here, driving from B to C, driving D, and riding from C to A, riding. These are the speeds. And the total time. Oh, we don't even know the signs, what the lengths are. So we don't know what, and so we let AB equal to little a, BC equal to little b, and CA equal to little c. So we give names. So the 6 unknowns here. This is A, this is B, and this is C. And let me just put the speeds in blocks. Because, so you got, this is the length of AB, and this is the speed, W. So we can work out the time that it takes from A to B. It will be A over W from A to B. And from B to C, the distance is B, 6 unknowns. A tough problem. Distance from B to C, and the speed is D. And here, from C to A, and then we call that C, and is riding. This takes 15.5 hours. Okay, now we finished that first part of this long story. Now they say driving a car from A to B. So this thing changes now. From A to B, if you drive, so driving a car from A to B, riding a horse from B to C, from B to C, riding here, and walking from C to A. This is the third part. We stop there. He could make this journey in 12 hours. So this is a similar kind of situation there. So now we can make it A over D plus B over R, right? This is the same thing here, plus C over W. Now this gives you 12. All right, so I've got a second equation. I need 6 equations because there are 6 unknowns. This is a monster of a problem. Okay, let's finish that. A, B, and C. Just get this. Let's just get the C clear here. It's not very clear. All right. So that we stop there now. On foot, you could make the full journey in 22 hours. So the full journey, if he walks right throughout, the total distance he traveled is A plus B plus C. Let's give a name to this. Let A plus B plus C be equal to, say, X. So that's the full journey. Now, if he travels by foot, in other words, when he walks, right, the total time he takes is 22 hours. So you have that distance over speed, the speed is W because he's walking, is equal to 22. Okay, so we took care of that one. On horseback, that's riding, 8.25 hours. So again, the same distance, X, right round, but now is riding. Let's change the language for horseback rather than riding. So that is 8.25 hours, 8.25. So I'm there now. And by driving a car, it's 11 hours. So you got X over D, that's driving. Of course, that will be faster than the other two. Walking is not bad comparing to the others. Right. Anyway, so you've got that. So we are here now. Now, walking 1 kilometer, riding 1 kilometer, and driving 1 kilometer will take the person altogether half an hour. So if the distance is 1 kilometer, and he's walking, the time taken will be 1 over W, walking 1 kilometer. Riding 1 kilometer, there again the distance is 1, and riding, that's the time that you will take. And driving, the time that you will take here, these are the 3 times you will take to walk, ride, or drive 1 kilometer. Altogether, it'll take half an hour. So that, remember, this is in hours now. So we've got, everything is in hours. Okay, so you got 3 equations. Actually, you got lots of other equations here as well. You've also got A plus B plus C is equal to X. That's another equation. Okay, so you got 1, 2, 3, 4, 5, 6, 7 equations with 7 unknowns. Although it looks quite frightening, But watch. We can do it. You see, there's 1 over W here. We know is 22 over X. 1 over W. Because divided on both sides by X. So you'll have that this is 22 over X. Likewise, 1 over R. And this is 33 over 4. So 33 over 4 X. Because 1 over R is 8 1/4 over X. So you can write it like that. And 1 over D is 11 over X. Now you see, you only got one unknown here. Somehow you cheated our way through here. So you get 1 over X, take it out as a common factor, 22 plus 8 1/4 plus 11 is equal to a half. Okay, so I'm running out of space. I'm going to just take out those. Be careful I don't wipe out any of my equations here. Okay, I know what W, D, and R are. They are walking and the speeds. So I'll take this out. And then I know that these were, and A plus B plus C is X, remember? So now I can calculate X here because 22 plus 8 1/4 is 30 1/4. And this is 11. 30 plus 11 1/4 is 41 1/4. So you got 1 over X. Then you'll actually see if you cross multiply, you've got is 2 times 41 1/4. And that gives you X, 82 1/2. So in other words, you know the total distance because this is your A plus B plus C. Okay. But not only that, now that you know X, then you can get W straight away. You see? So I'm just going to wipe out these bottom equations. I don't think I need these anymore. I've used okay, I've used all these to calculate X. So I know that X is now 82 1/2. X is 82 1/2. The total distance around those 3 towns. All right, so we've got, so 1 over W. So if you cross multiply, you get X is 22 over W. So 22W. So W is equal to X over 22. And that's 82 1/2 divided by 22. 82 1/2 is 165 over 2 times 1 over 22. And blissfully, 11 goes into this. 2 times 11 goes into that, 15 times. So you got 15 over 4, which is 3 3/4. So you got W is equal to 3 3/4. Let's just write that here. We calculated W, and we got all that. Now let's try to calculate R. R is X divided by 8 1/4. Of course, multiply. Now X is 82 1/2, which is 165 over 2. When you're dividing by 8 1/4, 8 1/4 is 33 over 4. So when you're dividing by 33 over 4, you're multiplying by 4 over 33. And blissfully, 33 goes exactly into this 5 times. 5 goes into this 2 times. And this is 5. So x is 5 times 2, or r is 5 times 2. So r is equal to 10. Nice. Fortunately, you're getting some nice answers here. Right? And then finally, your d, what is w. We've got, it's actually d. So x over d is equal to 11. So d is equal to x over 11. X is 82 and a half. Again, you have 165 over 2. Over 11. 11 goes into this 15 times. 15 over 2 is 7,5. So d is 7,5. So we're really taming the monster here. 7 equations, 7 unknowns. We already got four solutions. Okay, now we still have to get the other 3, and they are the A, B, and C. Right. So do we have any equations there? All right. So we can substitute for A, B, and C. Let me just take this thing out. I used up all these calculations. I don't even need these two because I've used all of them. I used all these to calculate the W. So now I've got 3 unknowns, A, B, and C. We've got A plus B plus C is 82 and a half. Now here you got A over W. Now W is 3 3/4. Hey, very unpleasant numbers. Plus B over D. The D is 7 and a half. B over D plus C over R. I'm going to substitute for these 3 things. R is 10. C over 10. That's the only respectable radius. And you got 31 over 2. Okay. Now to get rid of all these stupid fractions, yeah, if you multiply the numerator and denominator by 4, you get 4a over 15. If you multiply numerator and denominator by 2, you get 2b over 15. You don't have to do anything here. This 31 over 2. I still got fractions, but I can take the common denominator, 15, 10, and 2, I think 30. Multiply right throughout by 30. So when you multiply this by 30, you get 8a, because 15 times goes into 32 times. Multiplies this by 30. So it's 4b. Multiplies this by 30, you get 3c. Multiplies this by 30. Oh, you get 15 times 31, which is 360. 15 times 31, 465. Another astronomical number. Right, so that takes care of this top equation there. Let me just wipe out all these which we used to calculate the second equation. We've got A plus B plus C. We have the second equation, and we want another third equation in those same 3 unknowns, and then we'll be able to solve. Now, here you got A over D. What is D? 7 and a half. Plus B over R. I'm going to the second equation now. B over R. What is R? R is 10. And C over W. W is 3 3/4. And that is equal to 12. That's the second equation. Okay, this is 15 over 2. So you can multiply top and bottom by 2. You get 2a over 15. No need to do anything here. Multiply top and bottom by 4. Get 4c over 15. In a fraction, you can multiply numerator and denominator by the same number. Equivalent fractions. Okay, again, you got, oh, wait a minute, you still got 30 as a common denominator. Multiply right throughout by 30. And what do you have? You got 4a. Multiply this by 30, 3b. Multiply this by 30, with 8c. Multiply this by 30, with 365. 360. Oh, okay, so I don't need all these. Fortunately, all this has been recorded, so although I am rubbing it out, you can always get it. So how do you solve 3 equations with 3 unknowns? Very similar to 2 equations and 2 unknowns. You'll have to eliminate one of them. So I've got a, 8a, and 4a. I can multiply, for instance, I can get rid of the a here. We call it 1, 2, 3. So if you take 2 minus twice this, 2 minus twice 3, right? That'll get rid of the a's. So you got this minus twice that. 4b minus 6b is minus 2b. Oh, okay. Let me create a space here because I don't need these now. I cleaned it up by these 3 equations at the bottom. Even that too I don't need. I substituted x equals. So what we've got here is this minus twice that. Rather, twice this minus that. Twice this minus that gives you 0. 6b minus 2 minus 4b is 2b. And twice this minus that is 16 minus 3 is plus 13c. Twice this minus that is 720 minus 465. Oh, Godfrey Daniel, that's 255. This is a big number. So now I've got rid of the a's using these 2. Now, I still need another equation. Get rid of the a again. Why don't we use those two? Because you don't, I don't want to multiply by 8. I'll get such huge numbers you'll get here. So let's try this. So I have to multiply this by 4. This minus 4 that. Equation 3 minus 4 times equation 1. 4a minus 4a is 0. 3b minus 4b. Okay, let's do it the other way. Multiply this by 4 and subtract. 4a, so you get 4b minus 3b. I don't like to work with negatives. So 4b minus 3b is b. And 4c minus 8c is minus 4c. And that is 4 times this, which is 330 minus 30. Oh, so finally you got B and C. So finally you can multiply this by 2b, and subtract. You get 21c, because 13c plus 8c is 21c. And you got 255 plus 60, which is 315. So 21c is 315. So c is equal to 315 over 21. This works out nicely because 21 goes exactly into this 15 times. Right, so we got C. Now you can substitute for C, and in this equation here, to get B. B is equal to 4C minus 30. From here, C is 15. So 15 times 4 is 60. 60 minus 30 is 30. So B is equal to 30. And now you know that A plus B plus C is 82 and a half. So these two are 45 together. So 45 plus A is 82 and a half. So A is 45 plus 37 and a half. So they ask, find the distance between the towns in kilometers. So those are the A, B, and C, which you got. And the speeds at which the person travels. Right? And we got all the three speeds. Oh my God, this was quite a handful. But I hope this journey through these 7 equations, the 7 unknowns, although it looked difficult, but there are ways of taming these monsters. Right? And you saw that we were able to get the unknowns very quickly by looking at the right equations. But at the end, we still had 3 equations, 3 unknowns, and that took a bit of time to solve. And the strategy there, you don't do that at school, is very similar to 2 equations, 2 unknowns. You eliminate one of the unknowns from 2 equations, and from another 2 equations, eliminate the same unknown. And then you have 2 equations, the 2 unknowns, as we saw. And then after that, we can, those are the 2 equations, the 2 unknowns, and then you can solve as usual. Okay.